let's see how to do integration by partial fractions here. So when we come to partial fractions for n6, all you need to do is first of all verify whether does this problem meet long division. So from here, I do that by comparing the degree and the numerator to denominator. So degree and numerator, you see there it's a 2, but 2 is less than a 4 because denominator here, if I open the bracket, my power will be a 4. So once the power of the numerator is smaller than the denominator, we don't need long division. So when you don't need long division, you go straight to calculating your partial fractions. So I'm going straight to that. So if I'm calculating my partial fractions, I copy my problem. Then I go to page number 6 of my formula sheet and simply compare my denominator to the 6 formulas on page number 6. So on page number 6, there are 3 formulas for partial fractions. So there is a formula. The first one has f of x on ax plus b to the power n. Let's call that the first. The second has f of x on ax plus b to the power 3 into cx plus d to the power 3. Then the last one has f of x on ax squared plus bx plus c into dx plus e to the power n. So those are the 3 formulas on the Math N6 formula sheet, page number 6, that guide you to know what to do. So when I look at those 3 formulas, all I need to do is to compare my denominator and see which one is it closest to. Which of those 3 is my denominator closest to. So you see that here, your denominator must be closest to the second one, because with the first, you must have only one factor. Then with the last one, your factor must have a quadratic that cannot be factorized. So when I look at this, there is no quadratic. Then I've got 2 terms, all linear. So I'll just look at. So as I was saying, once you are sure you don't need long division, you simply compare this denominator to the 3 denominators and see which one is a perfect match for it. So in this case, it cannot be the first because we already have 2 factors. Then the reason why it can't be the third is because here it's a quadratic, but we don't have a quadratic there. So looking at the formula sheet, I'm going to, okay, so now we have to write our partial fractions with the help of this formula. So on the formula sheet, you see it will be a on ax plus b plus b on ax plus b squared plus c on ax plus b cubed until when the x solves the power of the first person, then I can go to cx plus d and so on. So that's how that formula works until I reach the power 3. So if I compare it to this, so since I'm only ending at the power 2, it means I'll take my a on 2x plus 1 plus b on 2x plus 1 again, all that squared plus, now in this case you see that I'm going to skip c because there is no power 3 in my problem. So if I skip c, I'm going to d on 1 minus 3x plus e on 1 minus 3x, all that squared. So you can still choose to just call it a, b, c, d all across, but I'm just trying to stick to what my formula sheet is guiding me to do. So from here, I can now start writing my partial, because it's the process of calculating a, b, c, d. So I get 7 squared plus 2x plus 1. I guess we'll understand how I get to it. This is our LCD. So if you take this LCD and divide itself with 1, you multiply there, you get the numerator is equal to. Then I will take the LCD and divide here. So if I divide 2x plus 1, 2x plus 1 will take care of one of the 2x plus 1. So I'm having a into 2x plus 1 into 1 minus 3x, all that squared. So that will be my first term. Then I take this and divide the second person. 2x plus 1 all that square will take care of that completely. So I'm only left with this. So I get my b into 1 minus 3x all that square, then plus I go now to the LCD and divide here. 1 minus 3x will take care of one of that. So I get d into 1 plus 2x all that square into 1 minus 3x, then plus, I then take this and divide there. 1 minus 3x all that square will completely take care of itself. So if that happens, I'll be having e into 1 into 2x plus 1 all that square. So that's how far we have gone. So it's now time to figure out how do I get A, B, D, and E. So usually I tell students that in these three formulas, if ever you use this one, my advice is for you to expand. Then here is to choose numbers, and here you do both. So since I'm working with this one, I'm going to choose numbers only. So since I'm looking for 4 constant, I have to choose 4 numbers and substitute them until I get equations. So the first 2 are supposed to be simple because they will lead us straight to answers. So the numbers that I will choose, I'll just equate the denominators to 0. And I see my values of x. So if I say let x be equal to -1/2, how did I get -1/2? I equated this to 0 and solve for x. Then I'll substitute it right across. So if I substitute on the left, here we need the help of a calculator. It means I will replace every x by -1/2. So there I have 7 into -1/2 square plus 2 times -1/2 is -1 for that one. So -1 then plus 1. So that gives me my left side when I put -1/2 there as 7/4. Then if I go to the right side, I must be smart to remember that -1/2 came from 2x plus 1. So everywhere there is 2x plus 1, I don't bother myself, I'll just put -1/2 here. So if you take -1/2 times -3 is 3/2 plus 1 is 5/2. If you square 5/2, that gives you 25/4b. So from here, I can now solve for b by dividing both sides by 25/4, and that will give me 7/25. So that is how simple it is to get my b. Then I choose my next number. I'll say let x be equal to this time to get my next number. If you equate this to 0 and solve for x, you see that the next number is 1 and 3. So if you put 1 and 3 that side, it means you will get 7 into 1 on 3 square. Then 1 and 3 times 2 will be plus 2 and 3, then plus 1. So the left side gives us 22 and 9. If you go to the right, everywhere there is 1 minus 3x, you ignore that. So the first part we ignore it, we ignore the second and the third, so only put 1 and 3. So 2 times 1 and 3 is 2 and 3 plus 1, so 2 and 3 plus 1 is 5 and 3. If you square 5 and 3, you will get 25 and 9e. So that tells us that e is equal to, if you divide both sides by 25 and 9, your e will be equal to 22 and 25. So that is how we've got up to so far. And we have only succeeded to get 2 out of 4 terms. So we've got the value of b and e, so we still need a and d. So we need now to substitute more numbers until we get to a and d. But now, one thing we must remember is that the numbers we're substituting will no longer lead us straight to answers, because we can no longer get any other factors that are different from this. Even if you equate this to 0, it will still be that. If you equate this to 0, it will still be that. So you just choose any numbers of your choice, any 2 numbers of your choice, making sure they are different from this. So the only thing is to be smart to choose numbers that will not give you too much work to do. So if I start by saying let x be 0, I will know that the left side will be easy to calculate. If I replace every x there by 0, it gives me 1. If I go to the right, if you put 0 here and 0 there, you're left with 1 times 1, which is 1 times a is a. So we get our a. If you put 0 here, we're left with b. But you see, b is calculated already. So in the place of b, I'm putting 725. So I'll get 725, and if I put 0 here and here, I'm left with 1 times 1, then times g is g. Then if I put 0 here, I'm left with 1 times e is equal to e. And our e is 22 over 25. But looking at that equation, you will see that 22 over 25 and 7 over 25 are like things to 1. So on your calculator, you just take 1 minus 22 on 25, then minus again 7 on 25. So that gives me the equation being negative 4 on 25 is equal to a plus t. So this is my equation number 1. So that's how I get equation number 1 in terms of a and d. Then we need another equation in terms of a and d, so that we can solve the two simultaneously. So I've selected 3 numbers already. I need the last number. So I can say let x be equal to maybe a 1 this time, since I've not used it. If I put 1 there, this would be 7 plus 2 plus 1. That takes me to a 10. If I go to the right, if I put 1 here, I'll get 2 plus 1 is 3. I put 1 here, 1 minus 3 is negative 2. Negative 2 squared is 4. 4 times 3 is 12a. Then if I put 1 here, 1 minus 3 is negative 2. Negative 2 squared is 4. 4 times b. Remember, this is our b. If we multiply this by 4, that 4 is like 4 over 1. So 4 multiplies the numerator to give us 28 on 25. Then if we put 1 where there is d, put 1 here, 1 plus 2 is 3, 3 squared is 9. 1 here, we get 1 minus 3 is negative 2. Negative 2 times 9 is negative 18d. Then if you put 1 here, you see 2 plus 1 is 3. 3 squared is 9. 9 times e. What is our e? Is this one. So I just need to take 22 on 25, then I multiply that by 9. That gives me 198 on 25. So 28 on 25, 198 on 25, they are like terms with 10, so they can move that side. So if I take 10 minus 28 on 25, then minus 198 on 25, that takes me to 24 on 25. So I'm getting 24 on 25 is equal to 12a minus 18d, and that is equation number 2. So we now have 2 equations in terms of a and d. So all we need to do is make something the subject in one, then we put into the other. So we can still remember what our equation 1 is. So I can just bring my equation 1 closer, since it's far away that side. If I bring my equation 1, then this is my equation 1 and my equation 2. So it's now left for me to solve 1 and 2. So to solve 1 and 2, I can simply go through 1 and make a the subject. If I make a the subject, it means d will go that side. So 1 will be a becomes negative 4 on 25 minus d. Then I call this equation number 3. Since equation 3 was created from 1, I created 3 from 1, I can only substitute it in 2. So I will now substitute 3 into 2. And what does that mean? If I go to 2, I'll get 24 on 25 is equal to 12 in the place of a. I'm now putting negative 4 over 25 minus d, then minus 18d. So that's my substitution. If I open the bracket, 12 times negative 4 will give me negative 48 on 25. 12 times negative d is negative 12d minus 18d is equal to 24 on 25. So I can pull like terms together where negative 48 and 25 will move that side. So if it moves that side, I will just be taking 48 plus 24. That gives me 72. Since the denominators are the same, I'll be having 72 on 25 is equal to negative 12 minus 18 is negative 30d. So if I divide both sides by negative 30, that is to say 72 on 25, then I divide by negative 30. So this tells me that d is equal to negative 12 on 125. So I'm done with d. Now to get a, equation 3 is supposed to help me. Equation 3, remember, equation 3 is like that. It's negative 4 on 25 minus d, which is always negative 12 on 125. So those two negatives become a positive. So I just have 12 on 125, then minus 4 on 25. So my d is negative 8 on 125. So I'm now done with A. So this is A, not D. I'm now done with A, B, D, E. Now it's time to integrate. So I'm copying my integral of 7x squared plus 2x plus 1 divided by 2x plus 1 squared into 1 minus 3x squared dx. Then I substitute. My a is a constant, I take it out. A on 125. The function is 1 on 2x plus 1 dx. Then my b, what are you? B, where is my b? Okay, 7 over 25, another constant. So it's 7 over 25. The integral of 1 on 2x plus 1, all that square. Then my c, we get c, no there's no c, there's a d. We've got d as negative 12. D is negative 12 on 125. The integral of 1 on 1 minus 3x dx. And finally, my e, we've got e as 22 on 25. 22 on 25, the integral of 1 on 1 minus 3x, all that square dx. So that's our substitution. Now, time to integrate. This is where we must know which formulas do we need. Whenever we have this kind of a problem, you remember when we started, I said on the Math Basics formula sheet, when you go there are 3 formulas. I picked the second one. So once you pick the second one, know that there are integrals. For you to do that, there are 2 formulas that must be. Normally for integration by partial fractions, there is no way you can run away from this formula. So this is like U substitution for fractions. So I must use U substitution for fractions to do that. Then if you look, so this one will be used for these 2 terms. Term number 1 and number 3 that do not have powers. That is where we use them. But you see the 2 with powers, you don't have a choice, you must go to the power. The power rule is next to this formula on page 4, which is the integral of f of x to the power n times the derivative of f of x is equal to f of x to the power n plus 1 divided by n plus 1 plus. So if on page 6 you settle for the second formula, this is where you begin. So for the functions that are fractions but with no power, or with the power 1 at the denominator, we use this one. If the power is different from 1, we'll go to the power. So we're going to go through each and do our adjustment. So the right hand side, I have negative 8 on 125. So when I talk of adjustment, you know what I'm doing. I'm going to take that function, I put it in the place of f, then the differentiate I put on top, then I compare with the original problem. So 2x plus 1 compiles the position of f there. Its derivative goes to the numerator. If I differentiate this, I get 2, then dx. If I compare what I've written to the original, you'll see that this 2 is not available. So I need a number outside that will take care of the 2, and that's what I want to do. So I've adjusted this. Now if I go to the next person, 7 on 25, you now see that this one is a power. So I have to adjust it to look like this. So if I adjust that one, it means this will now be 2x plus 1 to the power negative 2. When that one goes up, it becomes negative 2. Then you need to differentiate the function and put next to it the derivative of 2x plus 1 gives me a 2. Now if you compare to the original, you see that 7 over 25 is there, 2x plus 1 to the power negative 2 is there, but this 2 is not there. So I need a number to take care of the 2, and that forces me to put another half outside. Then if I move to the third function, since it's a fraction and the power there is 1, it takes me back to the first one. So again, I will take 1 minus 3x in the position of that. So this is 1 minus 3x. If you differentiate 1 minus 3x, it gives you negative 3, which if you compare to the original, you see that negative 3 is not there. So the number that takes care of negative 3 is 1 on negative 3. And finally, on the last one, 22 on 25, it takes us back to the power. So I will get 1 minus 3x, all this to the power negative 2. Then if I differentiate 1 minus 3x as it is wanted here, it will give me negative 3 dx. But this negative 3 is not there. So if I need a number that can cancel the negative 3, it's just like I go down here and multiply that by negative 3. So it's the same thing like what I did here. I did here 1 over negative 3 is like you're only multiplying the positive denominator by negative 3. So that is how you handle these problems. Then you can now write down your final answer. So my final answer, if I multiply this constant out, it's negative 4 and 125. Then this one will be the ln of 2x plus 1. Then when I come here, it's plus 7 on 50. Then for this one, I just take the 2x plus 1, I put it aside and increase the power. So it will be giving me 2x. I will get in 2x plus 1. If I increase the power, it will be negative 1 and divide by negative 1. So that's my integral for the second. Then for the third, if I multiply this negative 3 will simplify negative 12 to become 4. So I'll get 4 on 125, the ln of 1 minus 3x, since I'm dealing with this formula. Then for the very last one, if I multiply this, it will give me negative 22 on 75 into, I get 1 minus 3x to the power negative 1 on negative 1 plus. So as an NC student, you can leave your answer like that, but if you want to simplify this, it's not a problem. We just need to take the negative 1 out, and this one comes down. So my final answer will be 4 on 125 in 2x plus 1. Then this becomes minus 7 over 50 into 2x plus 1, because now you see that the power that is negative 1 will drop. Then this negative 1 times that becomes negative. Then plus 4 on 125. This is me. Then 1 minus 3x. Then here, this negative will multiply that 1 to become a positive 22 and 75. Then this will go down as 1 minus 3x plus. So that's how to handle that problem. Thank you very much.